Nowadays, IP version 4 is so popular that anyone working with computers knows about it. Back in the old day, it was used to a major topic for Cisco exams or job interview questions for network engineer position. In this lesson, let's review IP version 4 to learn about it in general and its components. After that, we will learn about the rules to divide classful addresses and subnets. Then we will look into subnet rules and assignment. Finally, we will sum up our lesson with the keynotes. As you know, IP version 4 is the logical address assigned to network devices. It has 4 octets and each octet has 8 bits. Supposedly, we have over 4 billion IP addresses. Initially, to assign IP version 4 addresses to a network, they divided it into classful networks by slicing the first octet using the leading bits, where class A always have the first leading bit of 0. Class B always have the first 2 leading bits of 1, 0. Class C always have the first 3 leading bits of 1, 1, 0. You now can figure the pattern that the next class has the leading bit of 1 inserted into the leading bits of the previous class. Therefore, class D always have the first 4 leading bits of 1, 1, 1, 0. And class E always have the first 5 leading bits of 1, 1, 1, 1, 0. Using the classful network is not so practical that we have to divide the network into multiple subnets by borrowing the host bits. From there, we can figure out the IP range for each subnet. There are many reasons for subnetting. Here are a few. The broadcast domain. The smaller the broadcast domain, the more efficient is that network. Physical medium. An enterprise network usually consists of several types of network cables to connect multiple locations, which require different subnets. Security policy. We can easily set up a security policy to allow some sets of devices to access certain resources if they are in the same subnet. Role assignment. A set of devices with the same role must be within the same broadcast domain, which also means they must be in the same subnet. And the last reason is management and network designs. Let's talk about IP version 4 components. The first component is the address. The second component is the subnet mask, which is a series of 1 bits, then the series of 0 bits. The subnet mask helps identify the network bits and the host bits in an IP address. By performing the logical AND operation between the address and the subnet mask, we can figure out the first IP address in a subnet. It is reserved for network address, which means we can figure out the network that an IP address belongs to. The last IP address in a subnet, it is reserved for broadcast address. Therefore, the number of usable host addresses in a network will be 2 power of host bits subtract 2. Besides representing with the address and subnet mask, IP version 4 can also be written in the CIDR format, which is the address over the number of network bits. Let's look into the details of IP version 4 classful addresses. Class A, it has 8 network bits and 24 host bits. It always has the first leading bit of 0. So the first address in binary is this, and in decimal will be 0.0.0.0. Class B has 16 network bits and 16 host bits. It always has the first two leading bits of 10. So the first address in binary is this, and in decimal it is 128.0.0.0. Class C has 24 network bits and 8 host bits. It always has the first three leading bits of 110. So the first address in binary is this, and the first address in decimal is 192.0.0.0. Class D is not allocated to hosts and are used for multicasting. It ranges from 224.0.0.0 to 239.255.255.255. Class E is not allocated to hosts and are not available for general use. They are reserved for research purpose. It ranges from 240.0.0.0 to 255.255.255.255. You can now figure out the range for Class A, B, and C. As you may know, subnet is a shortened version of the phrase subdivided network. It is a method to divide a big network into multiple smaller networks. There are several reasons we need subnet, and here's the one. The numbers of hosts are limited due to the needs of the business. For example, the business only needs IP addresses to assign to 5 machines at a site. Then we only need 5 IP addresses for that site, or the size of the physical location. For example, if an office can only be set up with 10 computers, then we only need IP addresses for those 10 computers. We may need some additional IP addresses for network devices and future growth for the 2 locations in the examples above. However, any unassigned IP addresses are wasted because they cannot be assigned to another location. Therefore, subnet is a must because it allows us to assign IP addresses to many physical or logical locations and minimize unused IP addresses in each subnet. The best subnet design must have enough subnets assigned to all physical and logical locations, and it must have enough IP addresses assigned to all devices that exist in a subnet. So how do we subnet? Let's take a look at this example. We are assigned a class A network 10.0.0.0/8. We need to create at least 4,000 subnets from this network, and each subnet must have 4,000 hosts. And here is the network. In order to meet the requirements, we need to borrow 12 host bits for subnets. Therefore, the remaining host bits in a subnet are 12. After subnetting, we created 2 power 12 or 4096 subnets, and each subnet have 2 power 12 subject to or 4094 IP addresses to assign to hosts. And here is a subnet detail. Each subnet have 20 bits for network and 12 bits for host. Each subnet reserves the first IP for network address and the last IP for broadcast address. As a result, the number of host paths gets smaller. Let's talk about subnet rules and assignments. Rule number 1. One subnet for physical links. This rule assigns a subnet to connection type. For example, the point-to-point connection over here needs a subnet, and we usually assign the slot 30 subnet to a point-to-point connection. Or point-to-multipoint connection like over here also need a subnet. Rule number 2. One subnet per VLAN. This rule assigns subnets to physical locations like building, warehouse, or office. Within a location, a VLAN is created to group devices with the same role or functions, like devices such as camera, TV, and access points. Each type device, we create a VLAN and assign a subnet to it. And business functions such as accounting, IT, or operation. Each department needs a subnet. Or system functions like DMZ, production, QA, and development. Each system function requires a VLAN or actually a subnet. Internal systems like storage, servers, and desktops. Each internal system also needs a subnet. Let's read the keynotes for this lesson. This is the end of this lesson. If you have any questions, please put it in the comment section. Thank you very much for watching.